We're going to do a crash course in the 5Es. Some of you are very familiar with the 5Es, and so this will be a review for you. And others of you need a little more information. As much as I'm able to, I write my labs, or I convert my labs into 5Es. And I've done this for about 10 years. And I also I have led many workshops on the 5Es. So this will kind of explain to you the purpose and why in a brief crash course. There's a lot to learn about 5Es. This is just a brief part of it. So the 5Es have 5 E's: engage, explore, explain, elaborate, evaluate. And some of my labs, in fact, a lot of my labs just have one of each, but on occasion you will see more than one of each. For example, I have a water quality lab that has 3 different explore and explain. So explore 1 and explain 1, explore 2, explain 2, explore 3, explain 3, and then elaborate and evaluate. So it is a flexible arrangement. So they can be linear, like I said, where it's just only one of the 5Es, or they can be cyclical. And in AP Environmental Science, most of what I write is linear. But when I write for NGSS, it's more cyclical. There's more than one explore often, and that's just because of the NGSS standards. So why 5E? It is based upon how kids learn through something called constructivism. And you can Google what constructivism is if you want to learn more about it. But basically, constructing your own knowledge makes you actually learn it better. The 5E also allows me to easily fit in content, science practices. So these 2 items, the content and science practices, are really important for our class. And trying to, let's see, pen, so I can circle that. Here we go. Where we can, in this type of lab, I can weave them in together so I can get those skill building in with the content. And then for NGSS, I can easily put in cutting concepts and other needed items. For example, we're a Common Core state, so things that my administration wants me to weave into my science curriculum, I can easily weave them in a very authentic manner and meaningful manner into 5Es. 5E creates authentic learning. It's helpful for scaffolding and differentiation, and you can see that in some of the 5Es that I've built. So constructivism, the research on constructivism shows that when kids figure out the information, they learn it, but they need guidance. So just throwing a bunch of equipment at students and saying, figure out, design an experiment, is not what the research says is the best thing. They need to be guided to get the right answers, because they find that when students construct the wrong answer, it actually sticks in their brain, because that's the whole thing about constructivism. So we want to make sure that they're constructing the correct scientific principle. And that's through careful revising of 5Es. So when I see kids beginning to construct an erroneous or a problem with the lab, then I immediately revise and rewrite it to make sure that they are getting to the correct answer. So they need guidance in the 5Es. And you'll see I have guiding and leading questions throughout my 5Es to help students with that. So in an engage, it is designed by pure constructivism research. The engage is to access prior knowledge through either personal experience or previous academic learning. Either of those are great. The more local an engage is, the better. For example, this is a tree sitter that was in my town. Now that's very unusual because we are not in a forested area. And we're in part of my city of Santa Clarita is in an oak woodland. And so these are old, several hundred-year oaks that kind of dot the chaparral around my town. And we had a tree sitter there about 15, 16 years ago. And this is a picture of him. And my students really haven't heard about it. It was so long ago to them, and they're completely fascinated. So what that does is it creates a local connection, and that is really, really important. So alter my labs to give a local connection as much as you can, and any time that you can do that is great. Sometimes it's just previous learning, and sometimes it's just something that they've experienced at a personal level, not even an academic level. So the research shows that students need to refer back to something they know and they need to build on it. And so in the age of NGSS, let me move me around, we've talked a lot about phenomena, and so phenomena-based engage is also good. But however, in the classic 5E and constructivism learning cycles before NGSS came around, phenomena is not like the be-all end-all. And so you'll see that some of my engages are not really phenomena. I like to have engages a variety of things. Some of them is phenomena and some of it is not phenomena. All right, going on. So in Explore, students participate in activity that facilitates conceptual change. So what that means is they're going through this activity and I create the activity where the kids follow this direction and then they answer certain questions about what's going on. Then the next procedure and these questions, next procedure and these questions. So I intersperse thinking with doing, and this helps facilitate conceptual change. They develop the concept. I'm helping them through some guiding questions. I'm not telling them the answer, but I'm hopefully giving them some hints so that their brains go, oh, I get it. In an Explore, we avoid formal science terms at this point. Vocabulary comes later in Explain. In labs, very often when I write a 5E, actually in 5Es, I remove the introductory paragraph that tells them what's supposed to happen because that ruins the whole research behind constructivism learning. So no purpose statements there, no content standards, nothing like that. And we had to retrain in our science department and in the science in our school district, we had to retrain administrators that would come in and observe our science teachers because they were asking, well, where's the standards on the boards? Where's the objectives? And we had to tell them that that comes later when you are doing inquiry learning. Those things should not be out for the students because then you've already told them what they're supposed to learn instead of them constructing it themselves. And when they construct it themselves, they learn it better. Now, not all of my labs in AP Environmental Science are 5Es. Some of them are just a real simple short lab with an introductory paragraph because there's not always time to do a 5E. There's not always enough time for everything to be inquiry, and some of them are just quick and easy labs, not necessarily a 5E learning cycle. Okay, so in Explore, you will see that I have a lot of guiding or leading questions. Leading questions, I'm not, in the education world, sometimes there's this term called guiding questions. It's like the overall guiding question for this topic or unit or lab. That's not what I'm referring to. I'm referring to leading questions that are interspersed in a procedure that helps students understand the Explore and part of the Explain, which is the student's sense-making part. These are super important. Again, I combine procedure and questions to lead students to figuring out the scientific concept. And in a lot of my 5Es, you're going to see something called a claim check, which is a formative assessment spot check. So I can see, did they get it? Did they get to that? Did they construct that correct meaning from that lab? And so half of my explains are often student sense making, and that's an NGSS term that I've adopted for my class as well. And then part of Explain can be teacher driven. So sometimes explains in two parts that has leading questions and that's student sense making. And then I call it further explanations of vocabulary, which is the teacher-centered one. Now, it doesn't mean that the teacher is up there lecturing, although that could happen. It could be lecture. It could also, so formal instruction through lecture, but it can also be readings to do some literacy in there. If I have readings that are difficult, I use literacy devices. I took this free course from Stanford University about teaching reading in science. So it's a literacy course in science classes. All right, next. So again, I sometimes have what's called a claim check in my, at the end of Explore or Explain. I have this box and it says claim check, and I want to put this in more of them. They're not in all of them. And it works best when students are doing the lab questions as a group together and they're formulating this claim together. For a lot of my claims, it should not be hard. This statement that they make at this point should be rather easy because the questions embedded in the procedure have led them to this point. And sometimes the claim is a rephrasing of something they've already written down, and that's okay. So I tell the kids, don't overthink the claim. You should know the claim by this, and it might be a little bit repeated from something you've just written. So I can go around the room and I can just read what's in that claim check box, and then I don't really need to grade the other parts before that very much. And so I can just go around formatively check, are they getting it? Are they understanding? So in the next part in Explain, you can have formal explanations. You can introduce the vocabulary there. You can do readings, video clips, notes, a variety of ways to give them new understandings. Periodically in my 5Es, and I don't do this as much in my AP Environmental Science 5Es as I've written in my NGSS. So I am a curriculum writer for NGSS, and I put these more into the NGSS where we revisit the phenomena. So we start with phenomena for Engage, and then we go back to that periodically in the 5Es to discuss with students, or even have a box there revisiting Engage and have them now sort of explain what had happened earlier in that 5E. Oh, let's talk a little bit about how long 5Es take. So in my NGSS curriculum writing, it's usually like 4 to 7 days for one 5E. In AP Environmental Science, it's usually 2 days for a 5E. And that's due to time, and students can get through them more quickly. Okay, so elaborate. So elaborate can be a whole bunch of different kinds of things. So it can be deepened through new experience, what they've understand, what they've constructed. They can do an extension. They can apply knowledge to something else. They can do an activity with more formal science vocabulary, an extended lab. They can do math. They can do experimental design. They can do more reading. So elaborate is a variety of things. Can be a variety of things. And evaluate at the end. So this is your summative assessment. It can be formative too. It also can be left off of a 5E, so you'd end up with 4Es. Sometimes you'll see that on some of my 5Es. I've left off the evaluate because of lack of time, and so I just keep it, I make it part of the unit or exam. So I make the assessment just part of the unit exam, and I save a little bit of time that way in environmental science. So they can be formative, it can be summative, it can be a performance task. It doesn't have to be written. Sometimes I do oral lab reports on Flipgrid. Sometimes kids make a poster for experimental design. It doesn't always have to come sequentially, the evaluate. You can put evaluates maybe after other parts. So there's a lot of options you could do for evaluate. When you do have literacy, please give the kids some help. They need help especially you have to really kind of gauge your own class. Some of your schools may have stronger readers than others. Some of your schools may have more English language learners, and so these are all different ways here that you can provide literacy help. One thing I recommend is talk to an English teacher, make friends with an English teacher, because they know all about these things, these ways that you can help kids tackle complex text. And also your librarians are really good resources too to help with literacy. So when we talk about what do we do with handouts, so in my class, I give them the whole 5e at a time. For most of them, on occasion, like for my Toxins 5e, I give them kind of it in 2 different halves. And so that just depends on your style. The problem with giving them the whole 5e at once is that sometimes kids look ahead to the explain part and because they don't want to get anything wrong. So they're like, during the explore where they're trying to construct meaning, they're so afraid of getting it wrong. They're going to Google, they're going to look ahead, but that's not that many of them. And so it's really not that big a deal, I found, with my students about them looking ahead. But that is the reason why some people do 5e handouts separately. So maybe the first 2 E's in one handout, and then the explain in a different, and then elaborate in a different. But then the kids have a hard time keeping track when they're turning things in of what's what. And then so a lot of teachers end up doing the whole 5e in a packet. So for a lot of my 5Es, I have a teacher's guide, and it explains the thought process behind what I want them to learn and construct, and how these questions help them and where their misconceptions are. I have a lot of pictures, and I have some student samples. I don't have it for everything, but as much as I have, I am providing for you. And that's it. That's your crash course in the 5E.